Hey guys, welcome to Unit 1.1 Video 4 for Mr. McGee's 9th grade biology class at Arizona School for the Arts. This video series follows the biology coloring book by Robert D. Griffin, and today we're going to be looking at hydrogen bonds, ionic bonds, and covalent compounds. A quick reminder, an atom's electrons are found in energy levels that we call shells. The outermost energy level is called a valence shell, and when a valence shell is full, the atom is stable. Also remember that energy levels can hold different numbers of electrons. So the first energy level can hold 2 electrons. The second and third energy levels can each hold 8. And then after that it gets really crazy. We don't need to deal with it. At least not for biology. You might, if you're a super physics or chemistry nerd, but whatever. So the first type of bonding that we're going to look at is called hydrogen bonds. And these are weak bonds that form between hydrogen in one molecule and oxygen in another. And this happens because when hydrogen is part of a molecule, it generally has a very small partial positive charge. Whereas when oxygen is part of a molecule, it generally has a small partial negative charge. And so those partial opposite charges can form bonds of attraction. So look at this picture. It's a picture of 2 water molecules. The red parts are the oxygen, the yellow parts are the hydrogen, and you can see that the little plus signs indicate that the yellow parts, the hydrogens, are slightly positive, whereas the little negative signs tell you that the oxygen parts are slightly negative. So there's a small bond of attraction between them. They're sort of chemically attracted. They're not really sticking together, but they have a pull toward one another because of that opposite charge. Hydrogen bonds are important because they form between water molecules, and we're going to see that hydrogen bonds are really crucial when it comes to understanding most of the interesting properties of water. They are weak bonds, and it doesn't take much to disrupt them. In fact, with just a little bit of heat, hydrogen bonds can be broken. They're important to biology because they make up parts of the structures of proteins and nucleic acids like DNA. Here's an example of DNA. Look at the little pink dots. Those are the hydrogen bonds between the 2 sides of the DNA ladder. If it weren't for those hydrogen bonds, those 2 DNA ladder parts would fall apart. They would leave the important information of the DNA strand exposed to the environment, and it would become very easy to destroy it. That didn't make any sense. It would be very difficult to preserve the information in the DNA molecule. So by having these hydrogen bonds that hold the 2 strands of DNA together, that actually protects the information in your genes, and it means that you don't have a mutation that gives you 14 eyes and 3 heads and possibly superpowers. Ionic bonds are a little bit stronger. Actually, they're a lot stronger than hydrogen bonds. They're stronger bonds that form when one atom gives an electron to another atom. The electron donor, the one that gave the electron, becomes positive in charge. The electron acceptor becomes negatively charged, and that means the 2 have a bond of attraction between them. So here's an example. Sodium, if you take a look, sodium has 1 extra electron in its valence shell, and chlorine has 7 electrons in its valence shell. It's missing the 8 electrons that it would need to be really stable. So sodium has 1 valence electron. That means it's not stable. It can get rid of it, and it gives it to chlorine, and both of them become more stable. In doing so, sodium gains a positive charge because it's lost an electrons, and chlorine gains a negative charge because it's gained an electron, and voila! You get ions. You get these positively and negatively charged particles that are held together by their opposite charges. And if you let the water that they're in evaporate, they form these nice little even rows. They're called crystals. So lots of crystals are formed by ionic compounds. Covalent bonds are very strong. These are strong bonds that form between atoms that share their valence electrons. So they form during chemical reactions to create molecules. Here's an example of a very common molecule element, rather, in biology. It's carbon. Carbon atoms are everywhere in your body. They're a huge proportion of your body. And they're really, really useful because take a look at their structure. They have 4 valence electrons. That means that they can form covalent bonds with up to 4 other atoms. That means you can build carbon molecules into huge structures. Another thing that makes them really useful is that they form bonds in 4 directions. What this diagram is supposed to show you is that the carbon molecule can bond up or to the side or coming at you or going away, and it has this 3D structure. So carbon is really, really useful for building biological molecules because when you make molecules out of carbon, they can have a 3-dimensional structure. That is the end of this video. Whew. All right, please complete the corresponding review questions and be prepared to show your notes to me in class. Boy, am I tired. I think I'm going to go watch some Golden Girls and hit the sack. Bye.